some of the material that makes up the RAT instrument and the instrument arm. The company that made the RAT comes from Manhattan, and some of the metal was used from the Twin Towers that collapsed on 9/11. So that's a bit of a memorial to take some of the World Trade Center metal is now operating and doing scientific work on Mars. Okay, so I want to shift gears now to a mission that, just a little over a year ago is Mars Phoenix. And it landed, this is a really different kind of mission. This was just a lander, no mobility. The mobility here is it had a scoop that could dig down into the Martian soil. So this is a part of a panorama released on SOLS 13 to 36. This is where both rovers are very close to the equator. This Mars Phoenix landed at very high, I think it was about 72 degrees north latitude, to be the first lander or rover to explore the polar regions on Mars. So I'm just going to show you some pictures here. You don't see any blueberries, by the way, not in this region. A very, very different region of Mars. To be honest, this site didn't seem to me to be all that interesting. But there aren't any Mars Phoenix scientists from Brown University in the room, are there? Because they'd get mad at me if they heard me. Don't tell them I said that. Okay, so what they were able to do, though, is they started to scoop, and they actually, I don't know if this picture shows it, they actually found water ice just inches below the surface. So this shows that there's really, in fact, this picture, I think some of these whitish patches here are actually liquid water ice right below the surface. So there's still a huge amount of water on Mars. It's just that most of it is frozen in the polar areas. There's even water frozen even at lower latitudes as well, as indicated by data from the Mars Odyssey orbiter. So Jim Bell says, no longer do we have to speculate about whether Mars has potentially habitable Earth-like environments. We now know that it once did. We searched for the smoking gun, evidence of the planet's watery past, and we found that evidence either lurking there in rocks and minerals or popping out as soon as we looked up close. And these are just some more trenches. Now they ran into some real technical problems. You can take off your 3D glasses now. They ran into some let me just go back to this picture. They ran into technical problems. The idea was to dig up this soil, drop it into a heater, and then do a number of different samples. But the stuff was kind of cloddy. It kind of clumped up. And they only were able to do a couple sample analyses. I have to, from a technical point of view, it was a successful mission. I don't think from everything I've heard, there wasn't really a great deal of science that came out of this mission. I think the big result is there's water ice just inches below the surface in the polar regions. So if we ever want to send astronauts here, they don't have to bring a lot of water. All they have to do is melt the ice that's right there. It's sitting there right below the surface. And that's a pretty important finding. So just to conclude, and to get back to Bob's question at the beginning of the talk, is how big is the next rover? Okay, this is a model of Spirit and Opportunity. And this is the Mars Science Laboratory, was just about 1 week ago got a new name called Curiosity. Spirit and Opportunity were named by a 9-year-old girl in Scottsdale, Arizona, who sent a little poem into NASA, and NASA liked that idea, so they asked school children all across the United States, and I think even kids in other countries participated, to send in a name for the new rover. And a young girl in Kansas sent in the winning name, Curiosity. So you can see that this is going to be the name of the new rover. And this is going to just be a much bigger, larger, and more capable rover than Spirit or Opportunity. This is going to once again look for whether past environments on Mars were capable of supporting life. There's some negative with this, okay? One of the negatives is the mission is way behind schedule. This was supposed to launch this year, but it fell so far behind schedule they had to push it back to the next launch window, which is in 2011. The other problem is it was supposed to be like, like an $800 million mission. Well, it's way over budget. It's going to cost over $2 billion when all is said and done.
We'll get a bailout.
It'll be they've gotten the funding. But I worked at Goddard for a year. When missions go over budget, it's not really the taxpayers that have to pay that pay the price for that. Guess who pays the price? Other missions. So in other words, to keep this on schedule, to keep the mission alive, NASA's had to raid other missions, including missions that were on schedule and on budget. So this is going to be a really exciting mission, but it also means that other scientists aren't going to get to fly their mission, or they'll have to wait longer to fly their mission. In fact, this is putting a big delay into the rest of the Mars program. Like the later missions are seriously delayed because this mission is so far over budget. The other thing I'm not going to tell you, unless you ask me during the Q&A, I'm not going to tell you how this is being designed to land, because if it does, you're going to all go to your congressman on Monday and write your congressman and say, cancel this mission because it's not going to work. So if you want to ask me during the Q&A, I will tell you how.
Consider it asked.
Yes, question.
It looks like it doesn't have solar cells. Does it have a nuclear generator?
It's going to have an RTG, exactly. It's going to generate. And the thing is, that means it should be able to last a long time, like many years. But it also, creates risk, too.
Why is it over budget?
It turned out to be just much more complicated, and they were maybe, just to turn out to be more difficult and more complicated than they thought. And a lot of times, I shouldn't say this. I don't want to get in trouble with the scientists who I interview. When they propose these missions, they sometimes give overly optimistic budget projections, and that there was probably the original budget projection was overly optimistic. But I also want to point out, Spirit and Opportunity came in on time and on budget. Yeah. So the two missions combined cost about $800 million. So this thing's going to cost like $2.5 billion, or like 3 times the cost of the two rovers combined. There are scientists out there, okay, and I'm not going to argue with this, okay, who say, why are we building a new rover design? This design works. Why don't we just build more Spirit and Opportunities? You get economy of scale, and you could send them to all over Mars. It would be cheaper to build them, and you could put new instruments on them. You have the same basic design, same landing system, which we know works. Just build a bunch of these things, and you can do it cheaply, and you can send 10 of them, for a fairly low cost, and maybe 5 of the 10 fail because they land into a ravine or something, or a canyon. But you could get tremendous science out of just reflying these missions to different places on Mars. And if you want to do new science, you take some of the instruments and you put different kind of instrument on it, which are not, something that wouldn't be that expensive. You'd use the same cameras and just a couple different type of instruments. So you can make a real argument that this is a big mistake. But if it works, and it probably will, despite what I said a minute ago, this is going to have tremendous scientific yield and will make really great discoveries. Yeah.
How long is the power supply expected to last, and how much range do you take?
They're expecting to get many years out of it and go tens of miles. So if it works, if this, here's an analogy. Remember I said that Sojourner, the rover in 1997, lasted about 80 days and went 300 feet. Okay? Well, these things have gone 5 and 10 miles and have lasted over 5 years. Okay? So this is way better than Sojourner. The plan is for the Mars Science Laboratory, now called Curiosity, to be way better than